All right, now that I've shown you how to create the scatter plot and calculate the least squared regression line from the calculator, let's try another example. This time we have US population in millions and then the year 2008, 2009, 2010, etc. And so we want to draw a scatter plot of this data using technology. And hopefully we're going to get something that'll look like this. Now if you notice, I'm going to take a little bit of a shortcut with my inputs. Instead of typing in the numbers 2008, 2009, 2010, I'm just going to type in the last two digits, so 8, 9, 10, 11, 12, 13 for those years. And so I have a little note here on my graph explaining that 8 will represent 2008. So when I'm punching these in my list, I'll just use 8, 9, 10, 11, 12, 13. Okay, and it's also important to remember that the population number, that's in millions. So this means 304.1 million, or 304,100,000 people. All right, so how do we do this? Step one, we need to enter the data in our list. So let me clear out y equals, and I'll leave the plot alone because I'm going to use it again. And so I'm going to press Stat and go into Edit. And I have these numbers in list 1 and list 2, so I could arrow up and press Clear, Enter, and go over to L2 and do the same thing, Enter. But you can see I've already entered these numbers in list 3 and list 4. So I'm just going to use list 3 and list 4. But if you're trying this, you could put yours in list 1 and 2 if you want. It doesn't really matter at this stage. So I've got all my data in there. I've double checked. It looks good. I didn't make any typos. So phase 1 done. Step 2, let's go to stat plot. Second y equals. Turn plot 1 on. Mine's already turned on. Scatter plot is my type. Now I've changed it, so my x numbers are not in L1, so I have to make this L3. Second 3, and my y list L2, L4, second 4. Everything else looks good. Step 2 is done. And the final step 3, let's set the window. So I go to Window. My smallest x value is 8, and my biggest number is 13. So I'm going to go, how about 6 to 15 with a scale of 1. And then for y minimum, my smallest is 304, knowing that's millions, but 304.1. So I'm going to put in 300 for y minimum. And how about 320 for y maximum? The scale can be whatever you want. I'm just going to set it back to 1. So I've entered the data in the list. I've set my stat plot. I've adjusted my window for the data. So now I can hit graph. And there you go. We've got a nice straight line. And that looks really straight. So when you see this, you want to ask, is there positive correlation? Is it negative correlation? And how strong is the correlation? So the least squared regression line, that's what I get. So if you're answering a question on an assessment, you would want to write y equals, and the a value is 2.389, if I round to 3 decimals, times x, plus 285.22. And so that's my least squares regression line. The correlation coefficient, and we abbreviate that with R, and that's 0.999. You can't get much closer to 1 than that. That tells me that my data lines up in almost a perfect straight line, and it's a positive correlation. So an increase in year causes an increase in population, which makes sense. Estimate the population in 2005-2014. So let me go back to my calculator and get that regression line. So I've plotted the points. I want to calculate that regression line. So I'm going to go to Stat, right arrow over to Calculate, choose number 4, Linear Regression. Once again, I have to change it because I put my inputs into L3 and my outputs into L4. And then I'm going to store this in Y1. So alpha trace Y1. And now I calculate it, and I get what you saw on the screen. But now when I hit graph, it draws the line for me. Okay, now I want to use this line to estimate the population. There's a couple different ways to do it. I could, while I'm on the graph, I could just hit trace. But as you see, when I hit trace, on the top of the screen there in blue, it says plot 1. I don't want to trace the plots. That doesn't help me because I know what those values are. They came from my table. But if you hit up or down arrow, now it'll go to Y1, the line for me. And I can move along that line to get other values that were not in my table. And if I want to jump to a specific value, instead of using the arrow keys to try and get close, I can just type in the X value. So for 2005, according to how I entered it, that would be X equals 5. So I'm just going to press 5, and notice it says, oh, X equals 5. And I press enter, and it doesn't like that. So is that because I'm off my screen? So hold on, let's check. Oh, that's because my window was set. I'm going to set it smaller. Let's make it 4. Now I'm going to hit trace and get to the Y1. Now when I type in 5, there we go. So when X is 5, Y is 297.16286 million people. So in 2005, that's what my line predicted the population is. And if I want 14, I could do that as well. But you can see trying to trace the line from the graph isn't the best method. So what I'd like to do is show you a different method. Quit to the home screen. Second mode quits you to the home screen. And I'm going to call up Y1 from the home screen. Alpha trace Y1. And remember, it's a function. It doesn't call it F and G and H. So instead of saying F of X, I'm doing Y1 of X. So I'm going to put a parenthesis and put in 5. So it's like saying do F of 5 for the function that's in Y1. And so it'll go into the Y1 equation, plug 5 in for X, calculate the answer, 297.1628. And then for 2014, I'll do the same thing. Alpha trace, Y1, parenthesis, 14. So 318.66 million people. So those are our approximations for those two. Now there's another way too. We could go to the table and try and look it up in the table. There's a few subtleties to that, so we'll leave that for another day. And then finally it says estimate the population in 2022, compare it with the actual population. Well, I haven't looked up the actual population, but according to my graph, my least squared regression line, it tells me in 2022, the population should be 337, roughly 0.8 million people. Okay. Now, what I would like to point out is these estimates that we just figured out. In my table, the lowest year, the earliest year was 2008, and the latest year was 2013. So when they ask you to use your line to approximate 2005, that's earlier than any of the years in my table. And so we call that an extrapolation. We've gone beyond what my input values are. And likewise, 2014 and 2022, those are also extrapolations. Those go beyond what the data we have in our table. And it's generally considered extrapolations to be unreliable when we're using our least squared regression line because it's outside of our data. If, for example, 2010 was not in the table and we used our line to predict 2010, then that's called an interpolation. And that's considered reliable because it falls within our data values. So interpolation, oops, I had my answer for there. Put it down here. Interpolation is usually considered to be reliable, but extrapolation is generally considered unreliable. And so, to give you a better example probably, let's say I had a table of values for young athletes throwing a discus for track and field. And using the data, I plot it and I create a least squared regression line. That line goes on forever and ever, right? If I said, okay, well, somebody that's 105 years old, how far, according to my line, would they be able to throw the discus? It's going to give me a really big number because it's going to pull it off of that line. But obviously that's not going to make sense, and somebody that old probably cannot throw a discus at all. I also could have said a baby that's 1 year old or 6 months old, I could plug that into the equation and get an answer, but we know realistically that doesn't make sense. So that's why we say that if you go beyond the input values for your function, that's an extrapolation and it's going to be unreliable.